Here we have our last video lesson of our parallel and perpendicular lines mini unit, and it deals with writing equations of parallel and perpendicular lines. So we're going to try to follow a relatively systematic process in order to do that. So the first thing we need to do is determine the slope of the original line, which is kind of like our reference line. Then we need to determine what the slope of our desired, our new line, needs to be, based on the fact of it being either parallel or perpendicular. So reminder, parallel lines, the slopes are the same. So our slope of our new line would need to be the same as the original line. Or if it's supposed to be perpendicular, then the new slope would have to be the opposite reciprocal of the original line. We're then going to use the ordered pair x and y that were given in the problem, the appropriate slope based on the information, and plug that information x, y, and m into y equals mx plus b to then solve and find b. Once we have b, we also have m. We're going to write our equation in slope-intercept form. So example 1 says write an equation in slope-intercept form for the line that passes through the ordered pair 2, -1, so that's an x and a y, and is perpendicular to the line described by y equals 2x minus 5. So let's determine the slope of the original line, or our reference line. So that's this equation, y equals 2x minus 5. So the slope of that equation is 2. But if the new line needs to be perpendicular to the original line that we have, that means we need to take the original slope and make it the opposite reciprocal. So that would mean, therefore, perpendicular m needs to go from positive to negative, and 2 over 1 to 1 over 2. So we need to use that slope. Okay, so we already completed steps 1 and 2. Determine the slope of the original, determine what the slope of the new line needs to be. Now we're going to use x, y, and m to plug into our slope-intercept formula and solve for b. So if we start with y equals mx plus b, we've got our slope that we want is -1/2, x is 2, and y is -1. So we have -1 for y equals m needs to be -1/2 times x is 2 plus b. Okay, so let's clean it up with PEMDAS. We have -1 equals -1/2 times 2 is -1 plus b, and if we're solving for b, we're going to add 1 to both sides, which actually gives me 0 equals b. Now that I have m and b, I can write my equation, right? Here's my m, here's my b. So y equals -1/2 x plus 0. It's redundant to put the plus 0, so we'll just write it as y equals -1/2 x. For number 2, it says write an equation in slope-intercept form for the line that passes through 5, 7. So there's our x and our y, and is parallel to the line described by y equals 4/5 x minus 6. Okay, so we first want to determine the slope of our original, or our reference line. So the line y equals 4/5 x minus 6 has a slope of 4/5. Because we want our new equation to be parallel to it, that would mean that our parallel slope, okay, so this little symbol, little railroad tracks, means parallel, needs to be the same. So our parallel slope needs to be 4/5. All right, so we have an ordered pair, we have a slope, so let's plug into our y equals mx plus b formula and solve for b. So y is 7 equals m 4/5 times x, which is 5, plus b, which we don't know yet. Clean it up, 7 equals 4/5 times 5 is 4, plus b, and to solve for b, we subtract 4 from both sides, so b equals 3. We now have the information we need. We have our slope, we have our y-intercept. So y equals 4/5 x plus 3. Number 3. Write an equation in slope-intercept form for the line that passes through -5, 3 and is perpendicular to the line described by y equals 5x. So the original line has a slope of 5. Because we want a perpendicular line, we need to adjust that slope. We need to go from positive to negative, and from 5/1 to 1/5. So our perpendicular slope needs to be -1/5. So now we go to y equals mx plus b, and we can plug in x, y, and m to then solve for b. So y is 3 equals m is -1/5 times x is -5 plus b. So 3 equals -1/5 times -5 is +1 plus b. And to get b alone, subtract 1 from both sides. Therefore, b equals 2. So we now have our slope, we have our y-intercept. So we can write our equation in slope-intercept form. Y equals -1/5 x plus 2. And last but certainly not least, number 4, write an equation in slope-intercept form for the line that contains the ordered pair 8, -12, and is parallel to y equals -3/4 x minus 9. So the slope of our original line is -3/4. If we want it to be parallel lines have the same slope. So the slope of our new line needs to be the same, needs to be -3/4. Let's take our information, plug it into our y equals mx plus b. So y -12 equals m -3/4 times x, which is 8, plus b. Start simplifying. -3/4 times 8 is -6 plus b. When we add 6 to both sides, we get that b equals -6. Therefore, with a slope of -3/4 and a y-intercept of -6, we can write our equation y equals -3/4 x minus 6. Okay, so writing equations of parallel and perpendicular lines.